Hello and welcome to another organic chemistry lesson brought to you by Science Visualized. And today we're looking at halogenation of alkynes, and alkynes contain carbon-carbon triple bond. Then when you react that with a halogen like bromine and water, so when you have those two together, you end up adding bromine and OH across the double bond, and that addition is anti. So basically, you end up with this product where the triple bond now is reduced to a double bond, but now you've added bromine to that position and OH to that position. If you only focus on the double bond and the OH, that actually looks like an enol, and enols are not stable. They'll go through what we call keto-enol tautomerism. So keto-enol tautomerism, where you end up shifting that double bond to this position to form a ketone or an aldehyde. In this case, it will be a ketone, which will be more stable. So the product is actually going to be, and now the alcohol has become a ketone, and that will be the product. Now, if we look at the mechanism, you're starting with a triple bond, the alkyne triple bond, and that is reacting with the bromine. Now, remember, bromine has 6 lone electrons, which is 3 electron pairs, and one of those will act as a nucleophile. So say these 2 electrons will attack the alkyne, while one of the triple bonds, that's 2 electrons, will go back to bromine to form a cyclic product, while the other bromine will leave as a Br minus, where these electrons that were used for bonding will go on that bromine. So that will be Br, and then the 6 original electrons plus the new ones from the bond, so you get a Br minus. But on this other side, you end up with triple bond now reduced to a double bond, and that's bonded to a Br, the first Br, and that's a bromonium ion type intermediate. After this, the second step now will be addition of water. It has 2 electron pairs, and then one of those pairs will attack the bromonium ion type intermediate from the other side and open that 3-membered ring, so that now you end up with still the double bond, but now the Br has opened, and now you added the water. But because you used one of the electron pairs, you only have 1 pair left, and therefore that has a formal positive charge. So the last step will involve losing one of these hydrogens and its electron pairs flowing back to neutralize the formal positive charge. So you say minus H plus, and you end up with that as the product and the bromine at that position. And as you can see, this is similar to this, which will then undergo the keto-enol tautomerism to give you the final product. Thank you very much for your time. If you enjoyed this presentation, please like the video and also subscribe.